Okay, this video is all about orbits. So, what exactly makes a planet orbit around the sun? Now, you may already know the answer to this question. Gravity, but why? Okay, let's start with a little mini discussion on what gravity is. So, gravity is this force that acts between objects with mass. And that means that any two objects with mass will be attracted towards each other. That's right. Have a little look at the room you're in now and all of the objects around you that have mass. You are currently being attracted to all of them. It's just that that attraction is very, very weak. So you don't really feel the effect. In order to really feel the effect of that gravitational attraction, we need the force between the objects to be larger. And the more massive the objects, the larger this force of attraction is. That explains why objects fall down towards Earth. Earth, of course, is actually really massive, and so that force of attraction is great. So Earth pulls all the objects on Earth towards it. And of course, if I dropped this pen on the moon, I would expect it to fall to the surface of the moon much slower. The moon is much less massive than the Earth, so that gravitational attraction is smaller. And we looked at this idea when we looked at weight and gravitational field strength. And different planets have different gravitational field strengths, depending on how massive they are. So, what does this have to do with the orbit of the Earth around the Sun? Well, the Earth and the Sun are pretty massive, and so there is a large force on the Earth of gravity attracting it towards our sun. Then I'm asking myself the question, okay, why doesn't the Earth just fall in towards the sun then? And it would if the Earth was stationary, but the Earth is moving. And since the Earth is moving, rather than this force pulling the Earth in towards the sun, which wouldn't be good, the force of gravity pulls the Earth round so that it's forced to move in this orbit around the sun, rather than flying off at a tangent. So the size of that force, the gravity, depends on how massive the Earth was, but it also depends on how far away the Earth is from the sun. The closer it is towards the sun, the larger that force of attraction is. So imagine you're a random planet orbiting around the sun, and you're moving just fast enough so that the force of gravity from the sun is pulling you into that circle rather than pulling you in towards the centre of the sun. If you move further away from the sun, and that force that the sun now pulls on you with is smaller, then you don't have to be going as quickly to avoid being sucked into the centre of the sun. Now let's imagine that you get really, really close to the sun and that force of gravity gets really, really large. You have to move really, really quickly, remain in that orbit. So different things orbit in different ways. Planets orbit around the sun in an almost circular orbit, and moons orbit around planets in an almost circular orbit. Artificial satellites can orbit the Earth in a variety of different ways, depending on what they are being used for. Very often though, we do put artificial satellites into circular orbits too. A natural object which is not in a circular orbit is a comet. In fact, a comet's orbit is highly elliptical. I'm thinking about the stuff that we just discussed. When a comet is really, really close to the sun at this part of its orbit, it must be going pretty quickly, and as it gets further and further away from the sun, it starts to move more slowly as it's orbiting at that larger radius. Okay, hope you found that helpful. Please download the notes, give us a like and subscribe. Thanks for watching.